So today we'll talk about Resque, what Resque is, why we use Resque, and how we use Resque. So first, about 5 years ago, we started our company. This is not again. So we started a company, Soy Super, and mainly Soy Super, what it does, it gets all the prices from online supermarkets. So we scrape a lot. Last year I gave a talk on scraping, and we need something to manage all these cows, because scraping is something really strange where things change outside of you. So your test can be easily done. You should test against like the real world. So tests are not really helpful. It works for fixing things, but not for testing things most of the time. So failures happen in production, because if a site is down, if a site changes, something will get broken in production. So using a normal queue was a little bit of a problem. As I said, we expect a lot of failure. So what should we use? Well, my first option was to use Sherman, because it's a thing I was using in my previous job. It's great doing what it does. It's really fast, but it's almost a single queue. So if you need a lot of queues, you need a lot of servers. It has priorities, but that's it, like 3 queues. And it doesn't help in error management. So, okay, I can write that, of course. But the other problem was it has no visibility. You don't see what's happening on the queue. And having a lot of problems, like having visibility is great. So the other option is something I already used before, and it's called the Schwartz. It runs on top of MySQL. It can have multiple queues. They call it abilities, not queues, but it's the same. But you should write your workers by hand, and you need to add your abilities to your workers. And it has a little bit of error control. Mainly it can retry, but that is not what we want. We need a lot of queues. We need a lot of queues because we have several scrapers, several tasks writing to the database. We have we have a lot of workers. Nowadays we have around 2,200 workers, different workers. So, well, what can we use? So, other things, we expect failure, as I explained, and we need some tool to see what's happening in the queue. We need tools to retry when we want. We need to control what's happening with our jobs, with your failing jobs. So I was at home having a barbecue with friends, and yeah, they are Ruby programmers. And I was explaining my problem to them. And one of them asked me, "Do you know Resque?" And I said, "Yeah, it's this thing from GitHub, right? Yes, I think it's perfect for your problem." So, well, we were a little bit drunk at that time. But, well, I grabbed my mobile, I checked it out, and it looked perfect. I found this blog post, and it says Resque is a Redis bucket library for creating background jobs, placing them on multiple queues, and processing them later. And that night, well, everyone knows Redis. Redis is great. Redis is fast, and it has one property that's perfect for a queue. That is, if you push something to a list, and then you pull from the list, you pop from the list, it will be unique because it's a single process. So then I read this. Of course, you can read really fast here, but the important part is workers can be distributed between a lot of machines. That's what we need, a lot of IPs. They are resilient to memory bloat and leaks. I know my code is shit, so it has some leaks sometimes. Expect failure, like me. That's great. So queues are persistent. That's a nice property. It provides visibility into content. That's really what I'm looking for. Shows simple JSON, so it's easy to implement. It has a front end, and it helps you track failure. So it was perfect. So I see this thing that's Resque web, and it's an interface. Sorry. Yes, again, sorry. So I checked the interface, and it looks perfect. It looked like I really need this. So what's the problem? The problem is this only works in Ruby. So, well, for a day I was thinking about the idea of implementing it in Perl. I searched on Google and searched on GitHub if someone had already run my shop. There was a partial implementation, but I tried and it didn't work. So, well, I say, but, you know, Perl loves Ruby. In fact, we are the father of them. So, well, I just copied the repo. I replaced the RB in all the files. I put a PL. It still didn't work. So I started replacing class attributes with most class attributes. Still didn't work. So I started replacing methods and adding a lot of self and this shit on it, and it still didn't work. So I started doing like feature by feature, like translating tests from Ruby to Perl and code from Ruby to Perl and passing tests. And at some point, it worked. At that point, it worked, but it looked really rubbish. So, well, I did a little more work, and well, at some point I say, okay, I will release this kind of work. I need to go back to my shop. That day was scraper like a mad day. So I released, and we started using it. And well, this was my message. Perl is Perl part of the original Ruby library. It's intended to work using the same backend to share tasks and be able to manage systems using Ruby Resque. So my main goal was to use a web app. I didn't want to write a web app. But strange things. Since that day I started using the web interface. I want to write a web interface, but someday it will happen. Not today. So I was really happy with it. And, well, being Perl, this has docs, not just a fucking blog post. And it's free. It's like, the only thing I did was I was replacing comments on top of Ruby methods, just adding perl to it. And I didn't even have to write English. It was almost all done by them. I only had to document things I changed. And at the beginning I changed some things because I didn't understand how it works, but then I fixed it. So, okay, how we use it? How would you use it? How is it supposed to be used? Well, you initialize a Resque object, a Resque system, and you say, okay, this is my Redis instance. That's the only thing you need to run it, and that's it. Then you can just place jobs. In this example, you place a job of class my task in some queue, and the arguments are these strings, and that's it. This job will go to that queue, and if someone is listening to that queue, it will be done. So how you write that class, how you write that package, not the class. Well, you have to only create the package, install it in your perl path, lib path, and you need to implement a perform function. That was my first great mistake, that I didn't expect it to be an object. And this is like, well, yeah. But, well, this is simple. You get the shop object, that is a Resque shop object, and you can get arguments, and you can do whatever you want with it, and done. All the rest of the things is done by workers. Workers will dynamically load your classes, and it will get shops out of the queue. It will run with your classes, and it will control your classes. In fact, they will fork before that. So if you have leaks, that's okay. If you have something quite wrong, that's fine. It will catch the error, and it will place that failure into the failure queue. So you can see in your interface that you have a problem. You can fix and you can retry, and that's fine. But sometimes forking is a problem because it's really slow. So, for instance, we have a queue for shops that need to write to the database. So, like connecting to the database for each shop is like pain. So what we do is we use something, the attribute don't fork. It won't fork. It will leak if you leaks. And then okay, I can connect to the database and then start accepting shops. And done. Other thing that workers does, in fact, workers does everything in Resque, is to babysit other workers. Every time a new worker starts, it will check against the Redis instance which workers are running in your box, in the same box that worker is running. And it will check if that processes are still alive. If they aren't, all those processes will be collected and placed in the errors queue with an appropriate error saying this worker has disappeared. And if not, okay, everything will work, it will start, and that's it. So this is great because if your machine suddenly disappears from the space, at some point, if that machine starts again, the shop will be ripped and placed in the error queue, so we will notice and you can retry. So how you write a worker? Well, that's easy. You just say, okay, Resque, give me a worker. I will listen into this queue with these priorities. First, if there is some shop in this queue, it will fetch from there. When this queue is empty, it will fetch from this. And then this will block, and it will work forever. But there is a CLI, a CLI, that's much easier to use. So you only have to say, okay, Resque, listen to this queue. Again, this is the priorities, and that's it. It works. It will block forever and work. You can also, okay, you can say where is your server, your Redis server. You can define queues. You can say the interval for polling, because what workers does is it polls on Redis every time. Yes. No, it's just a less priority queue. It's a queue that will get attention on that worker only when the first one is empty. Yeah. It's great for workflow, for instance, because we have a lot of shops that are not really important to be done fast, but some that are really important to be done fast. So we place like in low priority queue the shop we need to be done sometime, and the others on the high priority, for instance. But we have a single worker doing both because we don't want to like a lot of processes. Well, we already have a lot of processes, not more. Then you can preload some modules. Okay. You can say you don't want to fork. You can say to set the variables flag into the shop, into the worker and the shop. So you'll get some info on your screen, and that's it. So, okay, this is how the library should work, but we don't like it. As I told you, I did a horrible mistake because it expects to have a package with a function and not a class, and we use all around moves. So, well, we started using it. I started using it, and I decided this crap, and I need my shops to be moved so I can evaluate arguments and use all the nice things. So, well, I suppose I send this, and I will provide all my arguments as a hash ref, like I was instantiating a moves object. And then, okay, how I managed to work with this. So our first approach was this. So we declare the package, and we declare another package that is a class. So what we do is we unpack the arguments, and we instantiate a worker, like the real worker. And we did some roles. And this is the most important one because it can get a shop and provide a lot of methods to work with the shop. And well, we accept the parameter for the email. And then we use another role that will provide us a send mail method, so we can send mail. So in this case, the send mail gets all the configuration for a config file and everything, and it works. And we can send mail from a lot of task now. And the rescue shop role is almost as simple as this. Our role is a little bit more complex, but this is the important bit. Yes? I don't know. Oh, yes. Let's see what happened with the next slide, but now it's... So, yes. And we used this method for a long time, too long time. So, well, we have like a lot of boilerplates, in our shops. And at some point, I was like copying one more time this thing, and it looked like, oh, no, I need to solve this. This is not good. So our second approach was this, still a lot of boilerplate, but a little bit less. Not that good. We use it for some times. And last week, I had the idea of doing giving a real solution to it. And I received a lot of emails of people using Resque and asking me how to do some stuff. And the truth is, I can answer easily because we don't use the way it's supposed to be used. So all the time I'm copying how we use the thing, and it's a little bit embarrassing. Yes?
What are you finding necessary to have in send mail?
In the send mail shop, it's not really necessary, but in our workflow, we dispatch a background shop to a class, and that class will dispatch a lot of background shop to other classes all the time. So we need access to a rescue system, and shop gives you access to that. If you see here, the shop is handling access to rescue and Redis. So if you need to raise, in fact, in our case, we have a method called push directly. So you push to the same queue you got the shop. So okay, this was not good. So last week, I was preparing this talk, and I decided to skip my shop and try to fix for once this problem. And I created a class called Rescue Worker class, and it's a funny name, it's great. and it let me use my workflow without any boilerplate. So you only have to use Resque worker class. It will load moves for you. It will automatically add the shop, rescue, and Redis attributes. And that's it. It works. And it will call run on it. So this is great. It works. I didn't try it myself, so please use and let me know. I guess I will start using it on the next job, and at some point you will start translating everything to it, but not now. I'm really open to changes, so if you want something to go into it or to get removed from it, just give me an argument and we can discuss about it.
The mail client role, does that have a job attribute?
This provides to your class that attribute automatically.
The job attribute.
Yes. Yeah. In this case, you will have the same use case as before, without all the wallpaper, but everything is the same. So, okay, this works. It has test. Please use it and let me know. So, yeah, I was happy. Okay, the original implementation has something called hooks. And a hook is just a function that will be called before some actions. So they define the action they believe was important to have some hooks. And there is some plugin for the original Redis client, Resque client, using it. And when I translate from Ruby to Perl, I felt like this was a little bit dirty. I didn't like the idea of the hooks, so I didn't implement it, and that's it. And at some point, someone asked me, "Oh, I really like this idea of having hooks. I need to implement this problem, and I need to do some hooks." So okay, I jumped in and I talked to him. And I proposed another idea that I had in my mind that I never needed. That was, instead of having hooks, to let the system have move roles that can be automatically applied to every object when it gets instantiated. So you can provide your roles for shops, workers, rescue, failures. Every class that is part of rescue can be plugged, and you can modify all the behaviors. So I implemented that, and okay, I never use it. I know there's people using it, but I don't use. Why I don't use? Because we were using this pattern. Once we have moves object, and once we have the run methods called automatically, it's really easy to plug around. It's just using around, using before, using after, and that's it. That's all I need to do the stuff usually people do using roles or using hooks. So in this case, this is a little example role to automatically retry sometimes. In by default it's 1. So this will run my original run, and if it fails, and it should retry, it will just push to the same queue it got the job. So that's it. It will push the same job. The only thing, it will increment the retries. The next time it won't get retry. And that's all it takes to start writing plugins. Error handling. Okay, having an interface is great, and you can check and you can retry 1, 2, 3, 10 shops. But when you really fuck up the thing and you have like millions of shops in that queue, well, you won't be doing like million clicks to retry everything and then million clicks to delete everything when others is stacking on the queue. So, well, long time ago I wrote this, and this is a little CLI to retry with some rules. So I can filter things. I can filter by queue, or I can filter by class, I can filter by error, or I can filter by arguments. And then I can say, okay, I want to retry, or I want to delete, or both. Most of the time I do both, or only delete. So this is how you use it. You just, in this example, I have replaced a little bit my code. This is still not part of Resque, but it will be, for sure. I'm just trying to realize how it will be part of it, because now it has a CLI that is Resque Worker, the one I showed before. And I'm not sure if I want to add a lot of CLI programs. So I'm thinking about replacing the one I have with something called Resque, but I can't use the Resque name because the Ruby gem already provides a Resque CLI. So I know, I need to find a name, and then I will add all this stuff to it. So, okay, this is how we use it, and we use a lot. And as this was a really common pattern, and some guy asked me by mail about this problem, okay, I added a method to the failures class that can do, well, almost the same I showed you before. The only difference is the code I show you, it will grab the shot without removing from the failures queue. It will replace on the original queue, and after that it will delete, and it can let it there. It's possible just to retry without delete. That's really slow when you have millions and millions of shots. So this method, what we do is it directly pulls from the queue and replace on it. So it's not safe. If your process gets killed and on half of it, one shot can be lost using this, not with the other method. So that's another thing I have to realize if I want to use this method or not in the CLI. I think I will use this because it's much, much faster. And there is the last problem. Well, probably there are more, but I think this is one of the most horrible problems we have with it. That's stalled workers. This problem, when it happens, well, if a machine goes down, when that machine goes up again, it will place the shots into the failure queues. But if that machine never goes up again, those workers will be hanging on the queue forever. So, well, the first thing is, if they have a shot, that shot will never finish. And the second thing is, well, it's not nice to have like 20 workers or more on top of your list of workers, because worker is ordered by how long they was running. So, well, this is a problem. So I wrote this other script that's almost the same as the other. You can filter by host, by process ID, by queue. These three things is only if the workers are working. So if this is not the queues the worker is listening, it's a queue that the job was fetched by the worker. You can filter for a class, on the class of that job, and you can filter by time. You can say 1 day, 1 month, 1 year, 1 second, whatever that time consists and pass. So you can say I want to delete all the jobs that were running for more than 1 day, because I know I have no jobs that take that long. Not our case. And you can list, so you get the process IDs if you want to cherry pick, or you can just delete everything. And this script has a little problem, that is, if you only use delete, it will delete everything. So another problem I need to fix before releasing. Well, this is the code that it does. I will publish the slides. I'm running out of time. So you can check there. You can ask me on the hallway where you want if there is something wrong. And well, that's it. Thank you.
So is there any question?
Yes.
Is it still compatible with the Ruby one? So can you push a job from Ruby and consume it in Perl?
Yes. Yes, it is. You can push both sides. Yes. No, when shop complete, it is removed from the queue, but the rescue system has a stats class, a stats module. So in the interface you can check the statistics of your system. In fact, our system is running for the last 5 years, and we have like. But that's it. If you need to give something back to send the shop, like in Sherman, it's really easy. You need to implement it. And in fact, we did, and we use something we call channels. And a channels is just another Redis array. So we push there, and on the API we fetch from there, and so we have communication. And the great thing about channels is you can launch. Oh, sorry. Yeah. It was me. You can split your shop into several workers, and all the workers will write in the same channel, and you get from the other side all the messages all together, and that's something great for us. Okay. Yes. Okay. The thing is, on the script, what it does, it fetch from the queue, yeah, but it didn't fetch. It reads from the queue. So it goes to position 1000. It gets the error on the position 1000. It reads it. It creates a new instance of it from that data, and it plays on the queue. And after that, it has to go back to that position and remove from it. So the Redis server has to compact the thing. So then you have 3 operations on the Redis side, and you have your perl code waiting for that. On the other case, I'm just popping from the queue. Just in one operation, I read and remove, and then I place. So I remove the slowest operation from it. I did some change in how classes are organized, but mostly that was it. Not for performance. In fact, I almost translate every method one-to-one. The only big change I did, and this was provided by a user, was some changes in how we manage errors, because in Perl you can have exceptions and splitting some stuff. That's it. Okay, thank you for coming.